Today, actually, we are going to talk about this internal application called APMS that has been built for more than a decade. And now we are transferring that legacy code and how we transfer that legacy code to the new architecture. That's actually a basic introduction to this whole scenario, whole story.
Yeah. Thank you, Almir. It has been quite a journey so far, right?
Yeah.
This transformation. So basically, like this is what APMS is. It's like an application that we use to streamline our daily tasks. But like as we are adding more and more features, like to actually help like the daily operations of the company, the size of the application became huge, basically. And not only that, so it was becoming harder to actually introduce new features, like, while supporting the performance. And at the meantime, the user base of this application, as the company was growing, the user base of the application increased as well. So we were hitting performance issues, we were hitting faults for no reason, and etc. So we decided to come up with a modern design for this application, more modular design, more scalable, more, how to say, something that we can actually support couple of more decades as well. Like, I know it's a bit big to say, but like, we are basically using cutting edge technology right now. So hopefully at least it will be one more decade, like supportable. So in this setup, like, what we are hoping to achieve in the end of like this transformation is, as I said, like a modular application with a microservice backend, like an ecosystem of microservices for different business domains, like different requirements, different modules, and etc. And on top of that, like a micro-frontend setup, like where actually different modules are represented with different UIs, different parts of the application. However, like the start point, basically where we started this transformation, is the microservice setup. So essentially, how can you divide like a giant monolith and the backend into smaller microservices? Like we essentially had to divide the data first, like, create small bounded contexts, denormalize data, and completely forget about transactional consistency at certain times, basically. And this did cause a lot of headaches. Like essentially, when we are moving towards microservices, we need to accept that we can only have eventual consistency. And we did have some trouble, like, with the denormalization, with the cutting the boundaries of a certain domain, like certain bounded context, but we are doing okay up until now. So, Almir, what do you think? Like, you have some strong feelings about transactional consistency, right? How has it been so far?
Yeah, yeah. I love these store procedures and database, the transactional database. Well, yeah, it was for a while like that. We had this one database, transactional database where the user were actually, and you can see there, like on the left side, that's what we had so far. Users are interacting with the UI and let's say saving something to the database and waiting for approval immediately when that gets saved. So now while we're introducing this new architecture, microservices architecture and everything, we simply cannot do that anymore. It has that thinking has to be gone. So we need to think about eventual consistency. So to actually each our services are actually taking care of their own data, and we are exposing those changes through in our case, service bus to actually to give the information to another services if they are subscribed to that, and so they can copy that information on their own side. So eventually the data is theirs. So like we have to assure that data will be there and users just get notified that everything is fine. That's it.
Right, right. So we are essentially defining owners of certain data points, certain aggregate routes, and nobody else actually can push any data, update the data, and etc. While this data is being synchronized to other domains, like as reference objects or whatever, basically, but there is a single owner and the data is parallelly distributed over service bus, essentially. And that's the idea about microservices, essentially, so each bounded context should respect its boundaries. It should not be like, how is it called, jumping onto another domain, basically, and these microservices essentially like containerized, deployed with their own repository and etc. But going further, basically going to the front end side of the story, we also have micro-frontends, right? Like, on top of the microservices, we have micro-frontends. So how does that work, basically?
Yeah, let me jump in there as well. So, like just brief introduction, we'll hear more details after this. So, original application had one monorepo, like one big web application, a solution where we store everything there. And then we did go from there, like we tried to separate it at least from one point to in a time. We started creating new modules on Angular 2 application. And then that one again ended up like in second, like we had two big monorepos, like with a lot of handling on their own. So we had to go from that idea to micro frontends, and then we created a POC for that. We saw that it's really good idea to go that way. So we actually, what's the idea behind this? Like you see on this image, like we have a lot of microservices connected to one frontend. So in this new scenario, every micro frontend will connect to its own service, and they will show the data. So the idea is to have one like one shell application that will combine, that will actually dynamically load all different micro applications there that we have. Like for now, I think we have more than 15 different modules, and we keep growing each month, I think each year. Maybe you're asking like why did we choose Angular? Simply we had more knowledge there, and the chemistry between developers and simply with Angular was better. So on know-how basis, we selected Angular over React or Vue.js because simply we knew more in Angular than on the other tools. This was just briefly about micro frontends, and now Eddie, you can give us more details about this.
Yeah, of course. Yeah, thank you, Almi. Thank you for that intro. So yeah, as you said, like we came up with the micro frontend simply because we realized how much benefit we got through the microservices when we implemented that for our backend architecture, and what benefit it brought to us. And we thought, wow, wouldn't be great if we could do something similar with our huge monolith frontend. And micro front-end architecture is basically just an extension of the microservices architecture style. It aims to apply same design principles as microservices architecture, and gives same advantages. Like you have smaller components with high cohesion, meaning single responsibility. Each component is autonomous, so it can be deployed independently. It can be changed independently without affecting the other parts of the UI. It's business domain centric, and it's resilient. You don't have to crash the whole application. You can just silently replace the errored parts, and of course, it's very observable. You can have centralized logging and centralized monitoring with it. That being said, we did came up to a couple of roadblocks and encounter there are some things that you should look out for. Basically, first thing to look out to, the thing is that this technology is still in infant stage, meaning it's very green. There isn't that much content out there, and the tools are still being worked on to provide help with orchestrating micro frontends. What we decided to use is a module federation plugin, which is integrated in a Webpack beginning with version 5. It allows you to reference program parts that are not yet known at compile time. these can be self-compiled micro frontends. In addition to that, the individual program parts can share libraries with each other so that the individual bundles do not contain any duplicate codes. Like Angular libraries, if all micro frontends are using the same Angular version, you don't need it in all individual bundles. Second thing we had to do is to decide if we're going to go with the mono-repo architecture or to separate each micro frontend to separate repository. You can also use Git submodules, within your mono repo, but we actually decided to go for completely separate repo for each micro frontend. And then also there's communication between each micro frontend. In general, you should keep that communication to minimum, and because it couples the micro frontends with each other, which you really don't want to. But in a real life, these communication do have to happen from time in certain scenarios, and basically how you can do this is you can do it through the URL parameters. You can wrap your micro frontend into a web component and then use their properties and events to communicate. And also shell application can put a message bus, into the global namespace, and you can use that. How we have set up our micro frontend architecture is we created a shell application that will serve as a container for all other micro frontends that are representing separate modules in our monolith frontend. Shell application will be responsible for providing communication to our backend microservices through, of course, API gateway. And also it will host all the shared components and widgets between micro frontends. Now, for the micro frontends, they are in a separate repositories. They will be completely autonomous. We will be able to build and serve them independently. So they will have their actually like separate URLs. Now, that's where the module federation plugin comes in hand. We will use it to expose all these micro frontends to be lazy loaded as a remote route. Doing that, we expect to save development time with shorter build time, and we expect to be able to push changes faster all the way from dev to environment, to production environment, since we'll be able to deploy these micro frontends separately. Yeah, so we are looking forward to challenges that are ahead, and hopefully we'll be able to figure it out and produce quality solution at the end.
Yeah, inshallah, right?
Yeah.
Yeah.
Of course.
I mean, it is quite a challenge. Like, we are basically modernizing both the backend and the front end of the application, like with how's it called, cutting edge technology, basically, So, but while we are doing that, we are also trying to keep APMS alive, right? Like, because we are still working in authority partners, we are still running our daily operations, basically. So we need to support it somehow without killing it. Like, we cannot just say like, let's stop development for a couple of months. We will provide you like microservices, hopefully, inshallah, and we will deploy it. Like, it doesn't work that way. So we are basically doing Strangler pattern, like, Strangler principles, like plan, basically. How it goes is basically you take like the main application and then you slowly, piece by piece, change it while without hurting the existing application. And in the end, like, when you actually take out one part, replace it with the new model, you actually deprecate that part of the old legacy app, essentially, So and there are certain things that you need to be careful about, but we actually have a plan. Let's call it a plan. So we have like 6-step plan, like while we are extracting a microservice and a micro frontend. How it goes is basically we define a domain like a bounded context, we transform it, we implement it, migrate from the old one, like the old legacy definition, and finally deprecate the old service, essentially, So before we started doing like this, executing this plan, we first had to put like an isolation layer between the client application and the backend services. So previously the client app was calling the macro services, as Almir put it, directly. However, we have now the APM, like API management services on Azure. So basically, the client doesn't even anymore care like who he is calling, basically who it is calling, which service, because like API management is actually redirecting the calls to these microservices, and they are ready to be extracted. Then our process starts basically. So the first step is basically like first two steps is defining and extracting the domain. So we identify the aggregate roots, entities, value objects, events, like so many other artifacts basically that currently exist that we are not even aware of, like in the current application basically. And this will actually prepare the basis for the domain implementation in the next phases. Then we take these artifacts like definitions and we go to the product owners basically. And then Almir, what happens? Like what do they say to these basically?
Everything happens. So yeah, this is like really interesting part of the whole story. Like, yeah, like you said, we first isolate domain and bounded context, and then we go to our product owners to map this. We are mapping this with our product owners on how we call them event storming sessions. We have few of them, like for one domain, even more. Like, and we define every action, every data model, all actors, comments, triggers, and so on. So this is the way how we actually include product owners in this whole story, like so they can see our side of story and we can see their side of story. So we are together there to build up this application and piece by piece.
Yeah, absolutely. And they are kind of like involved in designing even the architectural model behind it, right? Like even like unaware essentially by defining events, commands, actors, and etc. Everything is put on paper together.
Yeah, exactly. And this Miro, like we use this Miro, how it's called. Yeah.
And that really helped us so far, like with the domains that we transformed like into microservices. It really helps, and it kind of gave creativity to the product owners, right? Like they got like really interested, like come up with ideas, like new requirements, like how to expand the domain, basically.
Yeah, because
So
it's closer to them. They can see what
yeah,
happens, like
and
visually.
it was really fruitful. It was really fruitful up until now, basically. So anyways, like once we actually define the domain, like, what it is now and how it will be with like some additional functionality, some additional events and etc. We basically have, what we have is basically like a small part of the domain defined, like with the data contracts and with the operation contracts, because we already carved out like, which service methods, which DTO objects are already used, like between the client and the legacy service, basically. So from this point on, the transformation starts, because essentially what we have is like old MVC commands, like, get this, update this, save this, and etc. However, we are planning to have like a modern resource-based RESTful API, like where actually each method means something, like each endpoint means something, essentially. So in order to do this, we actually use API management policies to transform the service endpoints to create this nice API sets for the microservices. So we are actually doing a top-down design. We are first defining the operation contracts and the DTOs, like the data contracts for the services. And how do we do this transformation, Yusuf? You had some struggle with them, right? Like with the API management policies.
Yes, thank you, Jen. Well, it was a hard job, but eventually it paid off. And for me to further like illustrate what we did regarding APIM, if you don't mind, I will steal your screen for a few moments. So let's talk a bit about what we did with the APIM transformation, or what it is. So like Jan and Almir said, once we identify our domain, we extracted it, and now we are ready to proceed with creating the new API, the new gateway. So we basically just extract those endpoints and put them directly into the APIM platform. APIM is Azure API Management platform, and we basically create a shared API, and we don't introduce any changes to it. We just migrate the legacy endpoints there, and we call that the first version of that new API. And now I will show you just a brief screenshot how APIM platform looks like. Here on the left side, we see all the different domains, and we see our domain that we chose as an example. We see that we are looking at version 1. We see the endpoints here. They're just like manually added. And we see here on the right, like backend part of this window, we see which service is used as the backend for this API. In this case, this is our legacy core service that we want to replace with a microservice in the future. So this is version 1. And now we are ready to go with the actual transformation. So what is the transformation? We take this first version of the API, and we, for example, take any endpoint, for example, this post method, which is save procedure. And in this case, what we did is we actually created 2 endpoints out of this one. So from one, we got 2 endpoints. One is post, one is put. That basically does 2 things, create a procedure and update a procedure. So this is just an example of a transformation that we had to do for a lot of endpoints, and it changed the endpoint map quite a lot. And we call when we get these new endpoints, we call this the second version of the API. And these new endpoints are just mimicking the desired design of the how it should look like in the end, but it still targets the same legacy service. So we still are basically stuck with the legacy code, but we're just trying to mimic what we want to get. And basically the backend service stays the same because we don't want any changes yet. But here comes the third version of this API. With the only difference here being the backend service, because we didn't perform any transformation of endpoints in this part. We just changed the backend service, and we are now ready. We have 2 working versions. We are now ready to complete this strangler pattern. Here is another screenshot of APIM, just showing you how does the second version look like. Here we again see the endpoints, which are now changed or transformed. And here again, we are hitting the legacy backend service, so no changes. And to just show you that we are still, we are mimicking the actually how we want these endpoints to look like. We are using one of many APIM transformation policies, rewrite URI, to just redirect basically to just mask the endpoint, and underneath this new endpoint there is this old legacy endpoint, which is save procedure. And this is also the case for the post one. So this is just an example. And a quick view over the third version. As we see, we don't have any transformations here. We just have the backend service, which is changed. And now, once we did all of this, we are getting close to our final result, which is when our client, which is APMS, communicates through a shared gateway or shared API with either the new microservice, new backend, or communicating still with legacy backend. So these switches here represent feature flags, and we utilize them to let the new microservice backend coexist with the old one. So we will step by step start migrating towards it and strangling the legacy backend. So in a sense, we can, by utilizing more Azure functions, Azure functionalities of feature flags, we can somehow create almost like a beta environment for users, where we let a percentage of users still use the legacy backend, and then we set another percentage or the rest of the users use the new backend. So we can start testing it early, we can start improving it, and get closer step by step to fully deprecating the legacy backend.
Right. I mean, like, we don't even need to deprecate it, right? Like, essentially, since both of the services are running at the same time, we can basically just include like an anti-corruption layer in the new service and synchronize the data to the old service and keep them running side by side. And if something happens, God forbid, like, with the new service, we can always fall back to the old one, basically. Of course, it depends on the domain that we are transforming, that we are implementing, and so on, basically, Thank you, Yusuf. Thank you. So basically, once we actually have the transformations in place, once we are actually we have the old service contracts similar to the new service contracts, like so we can actually just switch the endpoint. We start with the implementation. We have the application contract. We just need to implement the microservice. It's it's like a day's work, basically, right? And like in the new implementation, we are following two strict principles, domain-driven development and clean architecture. Generally, they go hand in hand, doesn't matter. But since we spent this much time on defining a domain, defining the events and so on, it would be a shame not to use actually domain-driven development, basically. And as I said, like clean architecture is just like an added benefit to it, essentially, So about the domain-driven development, like Yusuf, can you give us some info about the principles that we are following and why?
Yeah, I would first start with that question: why? What led to this process? Well, before we had our system had some limitations. Our code base grew a lot, and it was really starting to get complex, like with the code and everything, with the functionalities. And when that happens, it got really difficult for us to keep everything organized and structured. And like over many numerous iterations to maintain a separation of concerns, separation of modules, of components was really challenging. And as our code base grew, that was really a hard task for us. Like before, Zalmir mentioned, in our MVC architecture that we had, model took care of all the business logic without defining or providing any clear rules on how to maintain the proper responsibility boundaries. And several patterns came to our mind to try to solve this problem, but there was still some risk of logic and responsibility leaks between components, between modules, and that puts maintainability in question a lot. And like on the other hand, for example, communication with our clients, our POs, business experts, whatever, requirements gathering, the consensus between the technical and non-technical part of our team to design and implement something or a system that will solve a problem. That process is constantly iterating, and there people can easily misinterpret the system, the requirements, and then that leads our project really off the grid, off the rail, and that is a problem, of course. One interesting problem that really, another interesting problem that we faced in our during our development is naming. When you have a lot of similar stuff stuck in a single monolithic application, gigantic application, it's really hard to distinct simple things like functions and classes, and we had problems with namings a lot. And that sounds like it's not a big problem, but actually for us it really is. And this is just another thing that is a consequence of our code base growing in that monolithic environment. And domain-driven design really came to our aid to attempt to solve these problems, and it tried to unite both the technical and non-technical part of our team to compromise and invent a set of practices so we understand the features, so we understand how we can implement different things, how to maintain them, and how to scale them. And we really started to improve upon that, and domain-driven design really helped us a lot. And I believe Kelvin can tell you more about the solutions, how we managed to fix everything with DDD. Isn't that right, Kelvin?
Yeah, for sure. Yeah, as you mentioned, we face a lot of issues. Among those with an example, the naming and that kind of stuff. So basically, we solve that by by applying those most of the DDD concepts. So once we extracted the domain and exhaust the process of identifying domain boundaries, so that allows to basically have a well-defined domain for each service. So we don't have that kind of problems anymore. So everything is sealed between each domain. So the main focus was design each service. So we make sure that to create an abstraction layer that allows us to decouple the domain core business logic from any other outer layer like persistence or infrastructure. So basically, we achieve this by defining our interfaces. So, like for example, we define repositories to persist the state of domain, so domain model. So that persistence can be implemented in the outer layers without compromising the logic in the domain. So like we did that basically with domain events. So domain events are fully decoupled from the domain logic. So of course we handle the logic in the domain and we publish domain events, but those events can be handled on any outer layer, and we can create a seamless integration with other services like publishing integration events, for example, that will give us the flexibility to have eventual consistency and that kind of challenges that we face when we are dealing with this microservice architecture. And as John mentioned, these go hand in hand with the clean architecture. So for such a complete design where models are not just plain old CLR objects. So we have those clean architecture concepts help us to maintain the code base as uniform as possible. So having this well-defined abstraction and is what made possible such a complex design. So yeah, because I don't think that it's possible just to go DDD and not have like a clear path in the architecture. So yeah, but I think Nirma, you can talk a bit more about it, about this topic.
Yeah, thank you very much. So you already said that we were aware actually what DDD can bring to us, like what kind of solution that can provide us in order to find solutions for our challenges. And by following the domain-driven development, we were actually targeting scalable and modern architecture, which will allow our business to adapt to changing technologies and interfaces. And that's actually the part where clean architecture comes into play. So what we wanted actually, we wanted to have a system that is independent of database or frameworks or any kind of other external agency. And we wanted to have system that is independent of presentation layer. As you know, APMS has two kind of, let's say, UI interfaces. So we wanted to have opportunity that anytime we can change the UI without changing the rest of the system and business logic. And of course, the most important one, we wanted to have system that is highly testable, especially the core domain model and its business rules. So as you probably know, and you can see it here, with clean architecture, the domain and the application layer are like at the center of the design. So previously in APMS, domain models were just handled as data objects. They didn't actually implement any kind of a business logic or validation. So domain objects were not going to the client, there were no serialization or data concerns because we were just handling with them within the domain. And that actually pushes the domain model to be like downgraded just to properties. But the main business logic was within the services, and we wanted to move those responsibilities from services to the domain model. So we were making the app layer thinner and the main layer, let's say, less anemic. So what we actually did after isolation of the certain domains, we started with the domain service implementation. So we have defined domain models, like models that we are dealing with, and domain events. And domain, again, was defining an abstract persistence layer and services. And those services were just giving like an access to the domain objects, and they were just like orchestrating them. So finally, the client part defined two like projects. One was for the data, and that were our DTOs. And on the other hand, other one was for the Refit interfaces. So any additional implementation of these different layers made up actually our deployable package, and that's how we did it.
Yeah, and it has so far worked for a couple of domains. We already, transformed, extracted, and etc. Right, like this clean architecture approach. Yeah, basically our goal is to actually just take this app and domain part, and you don't need to have a microservice. You can expose it through console app. You can, push it directly to a mobile app or something, basically like that level of abstraction from the infrastructure, like hosting environment, basically, So, but regardless, like once we have this implementation, basically, once we have our fat domain objects, we can continue with our process, basically. The next step is basically migration. Like essentially, since we actually followed clean DDD procedures and clean architecture, basically, the storage data is nothing more than application state, basically. So we just need to take it from the repository, push it to our new repository, let it be SQL, let it be Mongo, or any other API of Cosmos, basically. We use different tools, just transfer the data to the new repository, basically, application state persistence, essentially. So once this migration is complete, we have the data, we have the domain implemented. Next step is basically the deprecation. We essentially just flip the switch and the calls are redirected to the new microservice without the client app knowing even about it, basically, or the users, essentially, for that matter. So as you can see, there is lots of transformation going on both on the front end and in the back end. And this is lots of pull requests, lots of sleepless nights, lots of hours, like all the APMS guys are putting in, basically. However, this needs to be, of course, like controlled, all this source code needs to go in somewhere, essentially. So where is this all happening, Galner? Can you give us some info about like our source code repositories?
Yeah. Okay. Yeah. Can you just scroll down? Okay. So I thought maybe your screen stuck. Okay. Me again with my history once upon a time. So let's step back just a bit. So before we had this, yeah, we had this again had mono repo for everything. Like this big repository that was just piling up, getting bigger and bigger. At one point, we did separate it to few parts, like as you said, we call them macro services because they were like started like a microservice, but then just went up in a totally different way. So what we're actually doing now, we actually create a lot of repositories for every different module, for different microservices, even now for different micro frontends, and each of those repositories have source code, infrastructure, and DevOps part. So everything is in one place. To be honest, this separation from that macro frontend, actually the big one, the big repository to these small parts was a painful process. We had to figure out what part of code we need to separate, and also the part of that big arm, big infrastructure part, to separate everything to different repository, small repository that is only handled that one, let's say, microservice, and to keep other stuff working, not break everything. So it was painful, but it was really good. Now we have I don't know, 15 plus, or maybe near 20 repositories there. Each of the repository has a strongly defined policies, like at least 2 approvers for the PRs, for the code to get in the master, quality gate, etc. Also, we have a different branching. We have the same branching strategies for each repository. Like we have this hotfix, we have master, we have like feature repository, we have like we're following the one flow on our each of our repositories. So the idea here, the main idea is we can simply deploy small parts of the application to the production, and not to wait for everything like to be deployed. Like for example, you want to change some drop down, it's missing some item there, and then you need to wait like 2-3 hours to everything be deployed. But now we can simply push small PBIs to production easily in a matter of days, from the start to the end. Finally, the idea with this is to have everything about the service, including builds, infrastructure, and source in single repository. That's actually the end idea.
That's crucial, right? Like,
Yeah.
for the repository to have everything it needs so that the application can be deployed like to the destination. And it has been like quite complicated. Like as you mentioned, like we broke the whole mono repo into smaller repos, like macro repos. And we separated like ARM, we separated the pipelines and etc. And going forward, we now have microservice repositories, basically. Each repository having like a data persistence layer description, ARM, pipeline, and the source code as well, basically. And they don't even need to be written in .NET per se, right? Like we can even have Node.js or whatever, like per microservice, essentially, depending on the infrastructure of choice, basically, like, or for that domain, essentially. So one person who really struggled with this transformation from this gigantic setup to this was Yusuf. Like, he was one of the first, our DevOps engineer. Like, we don't actually have DevOps engineers, but I'm just referring to his work, basically, was Yusuf. So Yusuf, can you share your experience with us? Like, how did it go, basically?
Yeah, of course. Thank you, Jen. I had an honor to start with the separation of the first core service from the monolith, from the mono repo, and it was really tough. Like as Almir already mentioned, like it was really important that we initially separate those core services, those macro services, so-called, from the main repo. And what we did later was just transferred all the code base, created those CI/CD pipelines, and configured the infrastructure like the ARM templates. So it all now was separated into 3 different repositories, and it really paid off in the end. It was already a big relief. And in addition to that, in addition to just transferring the code base, we also managed to migrate the complete Git history of these services, meaning that all three new repositories really looked and felt as if they were isolated from the beginning. So we didn't lose anything. Everything was still intact, working, and it was a huge success. And of course, after we separated those three from the main repo, we kind of relieved our web project of the unnecessary code, mixed CI/CD pipelines, unused parts of the ARM template, and so on. So that also was a big success. We sped up things a lot, and now continuing to introduce the process of moving our services to microservice architecture, we came to the point, as John mentioned, where we had to perform even more separation. Each domain that was to turn into a microservice was separated from these three new services, as you can see on this image, and they were separated along with it with their own configuration files, pipelines, ARM configuration, and other specific parts. And now, because it's all separated, each of that new repository produces a single or a set of its own artifacts, like NuGet packages, Docker container images, and etc. And it really started to feel as close to the microservice architecture as it could. And regarding pipelines, we moved from large, complex, conventional task-based pipelines to smaller and more consistent YAML pipelines, and that really made development, source control, validation a lot faster and easier. There's also quite a big improvement when it comes to pull request management. It became way more efficient in a sense, like we can now focus on just validating and automating validations and unit tests and whatnot on just one part of the code base, and that was a huge deal for us. And all of this that I just said led us to now we have more than 10 repositories in our whole organization, and each one looks and feels really independent and with its code configuration. And I believe that it was truly a crucial step towards achieving the new microservice architecture.
Absolutely, absolutely. And especially like what you mentioned about independent repositories. By the way, there are like close to 20 repositories by now. It's like every day a new repository. So anyways, like that independent repository concept is what is important, basically. Like, you know, while we follow strict policies, like as Almir mentioned, like, you know, the reviewer policies, like branching policies, I don't know, like build and validation and etc. Each repository actually is free to choose what it implements to validate the code that is being checked in, basically. Like, you know, we check for unit tests, we execute static code analysis, like, you know, we do like ARM validation, so many other different specific to that repository checks on the code, like before the code can be merged, basically. Because as I said, like it's a bigger team and there are lots of pull requests coming in, lots of responsible people for reviewing, checking, fixing this code. If there was no automation, we wouldn't be able to handle it. Like, you know, as you can see, like this is like in last 20 days, I think 249 PRs created. Like that's like quite a big number, basically. So Nerma, can you tell us how do we manage this? Like how can we keep this close attention on each of these repositories, basically?
Yeah, you said the key word, you know, that's the close attention. So exactly like that, close attention is actually the key to any verification. So this is no exception, even with the PR verification. And even before the creation of the pull request, there are some, let's say, practices that we actually apply. And on APMS first, there is a branching strategy. Almir mentioned that. And we have also a naming convention that needs to be followed. At the beginning, this one was left for the developer to take about, but we introduced like a policy that will not allow you to create a branch which doesn't follow the naming convention or branching strategy. So you cannot push your local branch remotely, local branch to a development environment. So we were, let's say, guide by the fact that the more things we automate, the more time we can have for the actual code review. That's the reason why we have also introduced a Sonar Cloud static analysis automatically in our Azure DevOps pipeline, and we also have added like code coverage to the Sonar Cloud report. And these tools helped us a lot with the review, but they also prolong the development time. Well, you know that since the developer needs to meet the criteria set by the Sonar, looking at it as a long term, that will be like that will give us more benefits than we actually thought. So the first thing that let's say as a reviewer, but also as a developer, pay attention to when creating or reviewing the pull request is actual if the Sonar has reported some code smells or lack of code coverage, or if the quality gate is not satisfied. And after that, the main focus is around code itself. And we have some desired code qualities that we want to achieve, So the first thing that we need to check whether the code meets the production requirement. That's the main focus. And if the code is well organized and understandable. And of course, if the code potentially maybe adds unnecessary performance overheads. So overall, the code needs to follow good practices. And that's something we always keep in mind. And I already have mentioned the code coverage. And by mentioning that, I wanted to point out that one of the most important part of every pull request verification are actually unit tests. We tend to include unit tests as a part of each new pull request, so it doesn't matter if we're talking about some new requirement or bug fix. If the ticket is fixing a bug, there should be definitely a test that makes sure that we don't have to fix the same bug again. So these are like my focus points on pull request verification, but you already know that we have multiple teams in APMS. And here is the thing that I want to introduce Edin as another team lead, and he will maybe tell us his thoughts about the reviewing of the pull requests.
Yep, and thanks, Naima. Thanks. As you said, I totally agree with everything you said. We have these tools; they do help us a lot, speed up our code review time. But you still have to be careful, watch out. I personally like to always first check where that code will go. So we don't kind of during the releases, sometimes developers forget that it shouldn't go to master branch, then to release branch. So that's first thing I usually check. But yeah, I also think that there is a practice that I kind of enforced in my team, because you can check the code for the backend, and that's fine. But when it comes to the UI changes, you really cannot see all that just in the pull request. So what I think the good practice should be is that we have our internal demos inside our team, and it doesn't have to always be for the team lead. You can have team members showing each other the UI changes, and that way 4 eyes beats 2 eyes any day, and you can somehow you can see something that developer implementing that might miss due to high load on that PR or something. So I believe that's gonna shorten the delivery period in the long run, because you see those issues before the QA team takes over, and then they have to create bug and stuff like that, and you have to make changes, and it just kind of shortens that unnecessary load.
Yeah, you actually have a really good point there, Eden. I mean, as you said, like looking at backend code, you can always see what is going on and stuff. But like looking at the front end, like, without running it, you cannot really be sure if everything is according to requirements, basically, like, But thankfully, like, you know, we are in that stage like that. We don't actually need an environment, like, you know, to run the application, like at least existing environment at that stage, like that. We actually have really well-defined ARM templates, like that defines our infrastructure, that we can put up like a whole environment in like half an hour, up to half an hour, basically. And that's like a pessimistic, how is it called, estimate, essentially. So maybe in the future, in the near future, we can even go with like a GitHub flow where the pull requests are actually deployed to a distinct environment where it's tested, demoed, and etc., and only then merged into the master, basically, to actually go to the higher environments. But like, as I said, it's all thanks to our infrastructure as code approach, basically. Like all the resources, all the services that we are using within the application ecosystem, it's not just one application anymore, it's a bunch of microservices, are defined in small ARM templates, basically. These ARM templates are configurable, like, you know, they are actually defining different parameters for different environments and etc. So we can just deploy like parts of the application, like to the required resource groups, to required subscriptions, or you can actually add on the existing resources. Like you want to create a subscription on an existing topic on an Azure Service Bus instance namespace, basically, we can actually do it like from the subscriber service. We don't need to deploy it in the main template, essentially. But let me not like, you know, steal like the excitement from this story. Aida, actually, who wants to give some introduction like to the history of this? Like, how did we come to this, basically?
Yes, I will. Thank you, John. So what really infrastructure as code contributes to us? So in continuous delivery pipeline, we have different policies starting with IAC. So previously, infrastructure management and configuration was done manually, so it leads to the problems, and of course, errors were unavoidable. But now IAC shifts the power into developers' hands. So in APMS project, we are using Azure as target platform, and so we decided to use ARM to provide our infrastructure. So of course, there are other tools that can be used like Terraform or SaltStack. So ARM packages are composed of main template and parameters file for each environment where we want to deploy it. So we use parameters to create variables. We're using variables in resources. Of course, we can deploy different types of resources like app service, SQL database, service bus, app configuration, API management service. So really advantage to ARM packages is that you can consistently deploy your infrastructure at any stage of development. And this is just another way that ISC can be used to accelerate the development lifecycle and to avoid discrepancies. So you can customize them according to your needs. When working with ARM, we should pay attention. Does configuration parameters match the environment parameters? Or are the resources in the same resource group? So previously we were using create and update approach. So where we had that giant release template, a resource template, sorry, where each resource we need was deployed to the target platform. So configuration of all services was at same place. Maybe at that time it was good. Everything was on one place, but it was becoming more and more complicated, hard to deploy, monitor, and implement. So now we are using new approach. So Selma will tell us more about it.
Thank you, Aida. So let's talk about where we are now. So we broke it apart, the whole monorepo into separate life cycles. So now we are using the incremental approach where the ARM packages are much smaller. It defines specifically what service needs of the application to run. It doesn't matter which resource group is deploying. We just care about a resource that is on the target resource group. So incremental deployment doesn't mean actually that each build has to deploy to the same resource group. So how we can be sure that ARM for some environments is valid? We can integrate templates into continuous integration and continue deployment tools, which can automate release pipelines for fast and reliable application and infrastructure updates. Before deploying, during the CI phase, we have our validation, meaning if code is checked in for the ARM template, we validate it for each environment. So we check dev, QA, UAT, production, and once the code is merged, we are sure that in the deployment phase, we will not have the issues. Moving forward, we have configuration as a code provided by ARM and Key Vault for securely storing and accessing secrets such as API keys, passwords, certificates, and so on. So we have ARM templates and matching configurations like dev, QA, UAT when we are deploying to the target platform. So this parameter file can refer to Key Vault value. For example, service has 3 parameters that are from Key Vault, but the application has no idea that there is Key Vault or infrastructure as a code. So when the resource manager is deploying a template with parameters, it actually connects to Key Vault, replaces parameters, and deploys to target platforms. So the application doesn't deal with Key Vault, only deployment pipeline and Azure Resource Manager.
Right. I mean, it does, like, how is it called? Take that responsibility away from the application. So like, it's like less services that it communicates with, less isolated, less like decoupled from like the whole setup essentially, you know. And basically like the reason we started using Key Vault essentially was mostly for like these passwords and etc. like that we were keeping for the repositories, right? Like, you know, we have a certificate for encryption, we have like, you know, a couple of DB server passwords and so on basically. So when we are creating the database, why not use the Key Vault, like the stored values from the Key Vault, and the application doesn't even need to access the Key Vault. Actually, like talking about all this infrastructure as code and configuration as code, like we need to mention database as code as well, because like for us, database is as code as well, like as well as the infrastructure. So Amir, what is the code here for the database basically?
Yeah. So again, we had this one repository, one database that we actually were deploying through using the DB project, like state-based, and we kept everything there, whole data structure, everything was there, like store position, everything. As we said, we use transactional consistency. But now, since we want to go with this, we are going with this microservices architecture, we need to start thinking, and we are already working with the inventional consistency. We said that as well. So we want to separate these the deployment of the database of the storage to different domains. So we encourage. We don't say like we can use like database. We should use database project. We can use anything like we already started working like with the migrations on one of our projects, and so we don't say migrations is good. DB project is bad, or other way around. So both state-based and migration-based approaches helps in doing seamless the database deployment. Like it's a common question, which approach is better? I don't know. Like it depends on project and the team requirements. So I just want to emphasize here that we have ARM to deploy the database server. Database is everything like one click, it's everything there up and running, and we can use it. So this is really good that we have set up that way. I want to say like just we're speaking about databases, and I know that we have one guy here that actually think that databases are not important after all. Am I right, Karen?
Yeah.
Let's not use database.
Yeah. If I say that aloud, I might get burned by witchcraft or something like that a few years back. But yeah, I think in the context of the domain, the database is not important in the sense that we basically in the domain layer we basically don't need to care about how the state is persisted, so we can have different approaches and different persistence infrastructure for each service. So and as you mentioned, the same goes with migration versus state-based database deployment. I mean, each approach can work under the correct circumstances, and depending on the uses and the use case of the service. I would probably lean more towards migration base since it's development is a bit easier and a bit faster when implemented correctly. But yeah, as you said, there is no silver bullet. There are just two different approaches that you can use it either way. So yeah, that's basically my take on that.
Yeah, you're right, Calvin. I mean, it really depends, basically. That's the answer that we give, right? Like, whatever you are doing, it really depends on the situation, basically. But regardless, like as Almir said, like, the point is that we can actually go to an empty environment. We can create a server, we create the DBs, and on top of that, we upload like whatever data backup that we have from production, like that is trimmed, that is scrambled, that is according to GDPR requirements, that provides us like the base of the database, basically deploy it to the target environment and deploy the delta on top of it. Let it be migrations or state-based, like, the DocPack file. We basically can create the database from scratch, like with the artifacts that we already have in Azure DevOps, essentially. So that's just like one part of the continuous delivery that we are talking about essentially here. Because like with all this transformation, like, all parts of the application, as well as the repositories, continuous integration, etc., continuous delivery is also affected, basically. Like we had to transform our release pipelines into YAML, like multi-stage YAML pipelines. Previously, we were just using pipelines and triggering classic release pipelines and deploying to target environments and so on, basically. However, now we actually have like a more, how is it called? More flexible pipeline structure where each service is deployed separately, essentially, So on this case, like, talking about the continuous delivery, even the environment, like referring to an environment means something different today than how it was before, basically. Right, Selma, like, can you tell us a bit about how we came to this, basically?
Yeah, actually, we were following monorepository approach where we had multiple applications all jumbled together in the same repository with different solution files. So we had giant release pipeline, as you can see on the picture, where we were building every part of the application, creating multiple artifacts so that we can deploy everything together. We deployed ARM and then deployed all services, including database, so all together from different artifacts. This was hard to deploy, monitor, because build time was really insane. So what we did is we created a multi-repo structure where each repository exposes their build and deploys their own NuGet packages, so other repos can use them. Previously, we had like 2 NuGet packages and all applications in one repository were using that. Also, pipeline speed is optimized. Before, one release pipeline was taking a lot of time to finish, about an hour, to deploy everything to QA, let's say, and now that's much faster. So what we are doing now, we are separating modules to microservices with defining clean architecture. We are defining which database we choose, like SQL or Mongo database, adding configuration in ARM needed for that specific module. So continuous integration actually covers the process of multiple developers attempting to merge their code changes with the main code repository of a project. So having a well-designed and smoothly running continuous deployment solution will be like the glue between the tools we use. So as you release code, often the gap between the application production, the one the developer is working on, will be much smaller. So continuous delivery picks up where continuous integration actually ends. So CD automates the delivery of application to selected infrastructure environments. We can say that teams work with multiple environments, such as development and testing environments, and CD actually ensures there is an automated way to push code changes to them. So now Aida will explain it furthermore.
Yes, so CD pipeline is a set of steps that your code changes will go through to make their way to production. So YAML-based pipelines enables you to configure your CI/CD stage strategy as code, where the pipeline definition is together with your code. So this enables teams to take advantage of pull requests, code reviews, branching strategy, history. So Azure Pipelines depends on seeing stage, job, and task. So stage, it is a collection of related jobs. By default, stages run sequentially. So each stage starts only when preceding stage is completed. Of course, if we don't specify that, it depends on property. Also, we can set which stage, so depends on which stage. For example, dev and QA depends on CI, UAT depends on QA. Also, job is collection of steps. So job can run conditionally, and it might depend on earlier job, but also it can run parallel. So in our microservices, jobs are run parallel. So we have job for build, ARM, Docker. So in build job, we have different tasks like sonar prepare, publish artifact, build test. In ARM, we are validating resources for each environment. Of course, in Docker job, we build and push the Docker image. Also to mention here is artifact. So previously we deliver artifact. So it was just web app packages that we're deploying, but now it is increased and we have group of artifacts. So essentially we are delivering Docker images, application packages, Power BI, SSRS reports. So as we move to CI/CD delivery pipeline, shapes and size of artifacts are also changed. Also to mention where our deployments go, it is going to environment concept. So environment concept is set of stages in your delivery pipeline. So for example, we have dev environment, but it refers to all services. So on each stage, we can see which pipeline we are deploying. So also environments are protected. So we have that concept of security. So we don't need to add checks, approvals into our pipeline. So for example, on production, we need at least 2 approvals from architects, program manager, or someone from infra team. Also, we have branch control. So if you want to push something to production from master, it will fail because it is built from master and not from release.
Right, and it actually makes our lives easier while dealing with the pipelines, right? Like we don't need to specifically add these checks into separate pipelines. It's all defined within the environment, basically. And as you said, environment is a jumble of everything. Like you can have VMs, you can have like, app services, you can have like, AKS namespaces declared, whatever, but it all defines like the target place that we want to run our application, basically, And like, as you can see, like we went through like, quite a number of stages, like, that we actually implemented certain improvements, like some changes, transformations, and etc. I just want to give some numbers basically on these changes, like how it actually helped the team. Basically, these numbers are, a bit old, like maybe a month old, but still it's relevant essentially. So according to these charts, like our average cycle time in the last 180 days is 45 days. That means that a PBI was committed and then deployed to production in 45 days. However, this average in last 90 days, 40, last 60 days, 36, last 30 days, 30 days, and last 14 days, 23 days, basically. So that means that like in the last 14 days, what we achieved is that a PBI is started and deployed to production like in 2 sprints. Basically, our goal is to achieve 14 days cycle time so that we can actually start a PBI and deploy it to production after all the performance testing, all the security testing, all the QA testing, and etc. Like, what we do actually to verify the PBIs that are being developed. And like similarly, like for the lead time, we have a decrease from 85 days to 61 days, basically. And this not only increases our delivery, amount of PBIs that we deliver, but also our release cadence. Like we were doing just 1 release a month. Now we are doing like 3, 4, 6 sometimes, like doesn't matter. We can just like go with one of the items like to the target environment, basically. So that's basically the whole idea was about, like to improve our delivery speed. We can actually deliver more quality and like, how is it called? More entertaining features to our user base, basically, while modernizing our application. So it's not only people like represented here, it's like a whole team, like, like a real teamwork. But I want to mention that in this DevOps transformation part, we don't actually have a specific DevOps engineer. All of the engineering team, both development and like, QA specialized people and etc. Everyone is a DevOps engineer. Everyone is creating their pipelines, dealing with their environments, implementing their environments basically. So it's the whole team that is actually managing the application's infrastructure as well, basically. So that's it. I hope you have questions and I hope you enjoyed the presentation.